The topic of this video is from Unit 3A on probability. The probability of an event A occurring is the likelihood or chances of event A occurring. The notation that we use to represent probability is listed there in the second bullet. The capital P followed by an open parentheses, capital A, which represents the event, and then the closing parentheses. And that is read as the probability of event A. Now, the probability of an event is a number between 0 and 1 inclusive, and it's defined as the ratio of the number of successes divided by total. The probability can be determined either from observing an event or from an event with equally likely outcomes. We're first going to take a look at finding probabilities from observing the event. The first example, a bag contains 150 pieces of chocolate candy as follows. It contains red pieces, brown pieces, green pieces, and yellow pieces. Choose one piece of candy from the bag at random. Find the probability of choosing the following. Our first probability question was we're finding the probability of choosing a yellow piece of candy. So how many yellow pieces of candy are there in the bag? There are 35, and there are 150 pieces total in the bag. So we're going to write our fraction as success over total. So remember, the number of successes goes on top, which is 35, and the total goes on bottom, which is the 150. Now we will need to reduce this. Top and bottom do have a common factor of 5. So let's reduce that fraction to 7 divided by 30. Now what's the probability of finding or of choosing a green piece of candy? Well, there are 32 green pieces of candy, 150 pieces total in the bag, so that does reduce to 16 divided by 75. We have a common factor of 2 on top and bottom. Now what's the probability of choosing a blue piece of candy? Well, if we form our fraction, we know we have 150 pieces total in the bag. How many of those pieces are blue? There are none of those. So that fraction reduces to 0. We call this an impossibility, simply because we have a probability of 0 of that event happening. Our next example, we're looking at probability from an observation, but we have data given to us in a table. A group of people who owned Nissan crossovers were asked what model they drove. The results are summarized in the following table. Choose one person at random and find the indicated probability. So our first probability question. What's the probability of choosing a person who is under 25 years old? So remember probability as success over total. We know that there are 432 people total, but the number of successes would be the number of people who are under 25 years old. That total is 168. Okay, we will need to reduce this completely. So that reduces to 7 divided by 18. Okay, the next question. What's the probability that the person does not drive an Xterra? Well, we still have 432 people total. How many of those do not drive an Xterra? Well, it's everyone except for the 71 people who do drive an Xterra. So we can subtract the 71 people from the total of 432. When we do that, we get 361 people. Now that fraction does not reduce, so we will leave it in the form that it's given. Now what about the probability for a person who drives a Murano? Once again, we have a total of 432. But how many people drive a Murano? Well, there are 162 of those people, but this fraction reduces to 3 divided by 8. Now, if in the question it does ask for the decimal, just divide the numerator by the denominator and round to the indicated decimal place. Now let's look at some examples where we have equally likely outcomes. So we're rolling a pair of fair dice. Okay, each die has 6 sides, and we want to find the following probabilities. Now you'll probably want to refer to your dice chart. It should be posted in Course Compass. That gives the outcomes, the 36 outcomes when you roll a pair of fair dice. So let's first of all find the probability of rolling a sum of 5. How many outcomes do we have total? That, of course, will be our number in the denominator. Now there are 36 different total outcomes, but how many of those add up to a sum of 5? Well, if you count those, you have the 4-1 combination, you have 3-2 combination, 2-3 combination, and the 1-4. So there are a total of 4 outcomes that have a sum of 5. So this fraction reduces to 1 divided by 9. What about the probability for rolling a sum of 12? Once again, we have a total of 36, but there's only one outcome that has a sum of 12. That's the 6-6 combination. So the probability will be 1 divided by 36. The last question. We still have a total of 36 outcomes, but how many of them have a sum other than 3? Now for a sum of 3, how many outcomes are there? There's the 2-1 combination and the 1-2 combination. So everything else sums to something other than 3. So these two are going to be subtracted from the total of 36 to give me a total of 34 out of 36. Now we will need to reduce this fraction as a common factor of 2, so this reduces to 17 divided by 18. Another example with equally likely outcomes. Suppose you draw one card at random from a standard deck of 52. You want to find the following probabilities. The probability of choosing a king. Think about this probability as success divided by total. How many total cards are there in the deck? There are 52. How many of them are kings? There are 4 of those. So 1 divided by 13. Right? You're counting the king of hearts, the king of clubs, the king of spades, and the king of diamonds. Okay, the probability of choosing a heart, once again, total of 52. Now there are 4 suits, the hearts, diamonds, clubs, and spades. So we are going to look at that as 13 of those 52 cards are hearts. So this reduces to 1 over 4. Now face cards. Once again, 52 cards total, but how many of those are face cards? Well, we have the king, the queen, and the jack, but we have those cards in 4 suits. So 4 times 3 gives me a total of 12 face cards. Now remember, the ace does not have a face on it, so it's not considered a face card. Now the 12 over 52 reduces to 3 divided by 13. Now the probability of a black jack, well, we have 52 cards total. How many black jacks are there? There are 2. There's the jack of clubs and the jack of spades. So this reduces with a common factor of 2 to 1 divided by 26.